Can you hear me now? Good. Well, it's section 11.6, and we're continuing with this study of surface area and volume. And we're going to go switch to spheres. So circular, 3D circular objects, um, like a basketball or an orange. So surface area, we're going to find surface area and volume of these spheres. So that's our goal. Our objective, our goal today is to find the surface area and volume of a sphere. All right. So a circle is a set of all points in space equidistant from a given point. So a circle, and I do not mean a circle. Wow. I meant a 3D circle, which is a sphere. And it's they're all equidistant from the center. I like the center of a circle. There's a center of um, a sphere. So a radius has one endpoint at the center and one endpoint of the sphere. And it's very similar to the radius of a circle. Only now there's way more radii because they're three-dimensional. It goes all over. Blank has both endpoints on the sphere and contains the center of the sphere. That would be a diameter again. All right, so these two diagrams kind of help us with a couple things, just visualizing things. Um, when when a plane and a sphere intersect, like shown in the picture, in more than one point, the intersection is a circle. So it's a cross section of a sphere, it would make a circle. If the center of the circle is also the center of the sphere, so if it goes through the center, like right here, then it's called a great circle. That means it's the biggest possible cross section you can make through that sphere. The circumference of a great circle is the circumference of the sphere. So the circumference of the sphere is the largest circumference that you can make. A great circle divides a sphere into two hemispheres. So that's where we get the two parts of a circle. So if you think of the globe, it's sorry, two parts of the sphere. If you think of a globe, there's hemispheres, and it's divided by um, the equator, and I can't think of what it is going up and north and south. But we have your longitude and latitude lines, which kind of make up, which are similar to what we're talking about here with these cross sections and these circumferences of these cross sections. Now, something important to look at is I like this drawing. It's like it's like a baseball. A baseball is a good model of a sphere. So to approximate its surface area, you can take apart its cover. So if you actually take apart a baseball, the cover, you take out the seams, it'll look like what's here on the right. And each of the two pieces suggests a pair of circles with a radius of r, which is approximately the radius of the ball. So if you picture it, there's like four circles there, a little bit off, but they're also a little bit smaller than what would be the great circle. But it averages out to find the area of the four circles, which would be the surface area of the whole ball. That's where this 4 pi r squared comes from. And that's our next theorem, Theorem 1110. The surface area of a sphere is 4 times the product of pi times the square of the radius. So super similar to the area of a circle, only it's times 4. It actually works out that it'd be times 4. So 4 pi r squared would be the surface area of a sphere. Very simple um, formula as long as you have the radius. So looking at example 1, find the surface area of the sphere in terms of pi. Well, if that diameter is 36, a radius would be 18. So we plug in the surface area would be equal to 4 times pi times 18 squared. And I'm going to have to use a calculator for that. And it ends up being 324. And then 324 times 4, if I put it in here, would get me 1296. So 1296 pi with the meters squared because you're dealing with surface area. That's how you find the surface area of a sphere. So do this one on your own. It says, what is the surface area of a melon we're assuming it's a sphere, with a circumference of 18 pi inches. Leave your answer in exact in terms of pi. Alright, so when working it out, I took the circumference is equal to 18 pi, and circumference is pi times diameter, so that means the diameter was 18, which means the radius is 9. And I can plug that in for the formula for surface area then to find 324 pi meters squared, inches squared. Made a mistake there. Inches squared. You could never tell. Alright, and that is surface area of a sphere. Let's move on to volume of a sphere. Volume of a sphere is similar again. It is closer. Well, it's pretty similar. The volume of a sphere is 4/3. So it's 4 over 3 times the product of pi and the cube of the radius. So a good way to remember this, since volume is three-dimensional, it's always cubic. It's r cubed for the volume. So it's 4/3 times pi r cubed. That's the simple formula. So if we use it for the same example in example 3, again, our radius is 18. So our volume would be 4/3 times pi times r cubed, which is 18 cubed. And I'm going to pull up the calculator and figure out 18 times 18 times 18. Then I'm going to do a shortcut to do 4/3 times that. So I'm going to divide it by 3 first. And I think it's divisible by 3. Yep, and then multiply it by 4. So that would be, what is it, 7776. 7,776 pi meters cubed. Volume of a sphere, 4/3 pi r cubed. Go ahead and try example 4. Actually, let's read it through first. Suppose the radius of a sphere is halved. So the radius is cut in half. How does that affect the volume? Oh, let's talk about that one. The volume. Well, if the radius of the sphere is halved, the only thing that's going to change is it's by r. So like an example, it'd be if the radius is 6, whoops, half of that would be 3. So it would be pi. Hey, let's use an easier one. I've got an easier example. 1 and 2. What are we doing 3 and 6? Let's do 1 and 2. Alright. 2, half of that was 1. So we got 4/3 pi times 1 cubed, or 4/3 pi times, oops, this one is 2 cubed. 1 cubed. So really the only difference is we're multiplying this one by 8, because that would be 8, and that's by 1. And I'm fairly certain it will work out that way every time. It's 8 times the amount. You can check it out for 4 cubed versus 2 cubed. 4 times 4 is 16. 6 times 4 is 64. 2 times 2 is 4 times 2 is 8. So it is 8 times bigger. So how does it affect the volume? 8 times more volume. Or 8 times fewer if you're going from halving. So fewer. Alright. I'd like you to do this one on your own. It says the volume of a sphere is 4,200 feet cubed. What is the surface area to the nearest tenth? So go ahead and figure that one out. You're going to have to find the radius. Hint, hint. So what I found was I plugged in for the formula for volume and I tried to solve for R. And I ended up getting R as approximately 10. Now, that was definitely rounded. Um, so then I used that and plugged it in for the formula for surface area. 10 squared is 100 times 4 would be 400, and you get your 400 pi feet squared. So that's how I did it. Did include a little rounding. To be exact, you'd want to keep pi in there, but that just makes it a little bit more messy. Okay, last example here. Number 6. Find the volume of a sphere Well, the circumference of the great circle is 36 pi. But keep in mind, the great circle is really the circle that would include the radius and the diameter of that sphere. So if that's 36 pi, then that means that's the diameter times pi, so the diameter equals 36, and the radius equals 18. And find the volume of that. Well, if you look up here, that is going to be exactly like this one we did up here. The radius is 18, so volume would be 4/3 pi times 18 cubed, which we got 7776, I believe, pi centimeters cubed. And that's the last one we're going to do right now. If you'd like to take a look at these last two, go ahead and try them. They're composite, or this is a half a hemisphere, finding surface area and volume of those things. A little more complex, but totally doable using the formulas we've got. And then finally answer these two last questions. How do you find the surface area, and how do you find the volume of a sphere? Just reflecting back if you remember. And that is all that we're going to do for section um, 10.6 at this point, surface area and volume of spheres. Again, it's just volume, or it's just formulas. If you can utilize formulas, you can find missing pieces if you need to. You can definitely find surface area and volume of many different shapes. So that's all for section 11. Have a great day.